Promise theory often says that there should be some kind of a seed to make people come together. The simplest way to get homogeneity is to have a leader.
The change agent, right?
Right, the change agent. Will people come together around a leader and be led? Will they follow? This is how the army works. It's not really by force, as we often present it, or by command, but the army works by having a collection of soldiers voluntarily commit to following the orders of a leader. And in different circumstances, they might have different people in command, as we can do with organizations as well. But there's another way we can form a consensus, and that's peer-to-peer. We can have everybody agree with everybody else that we're all part of the same group and we all belong together. You know, we can all hug each other, hug up.
The Scandinavian model. You go on for hours.
Exactly. It's much more expensive, of course, to maintain an individual relationship with a large number of people than it is to maintain a single relationship to a boss or a leader or a seed. And so in scaling terms, the natural way to avoid that cost is to have these leaders, and that forms hierarchies. And that's why, of course, many organizations have the org chart, which is very hierarchical. But I think what's happened in organizations is we've misunderstood the nature of that hierarchy and seen it as the right, as the permission for a leader to dictate to the people underneath or the systems underneath, to push commands rather than pull decisions that have been mandated from below. So if you remember the discussion from earlier, we talked about how a leader can be almost elected through a mandate from the people within a group to provide certain decisions as a service, and then those people will promise to accept the decision provided by that single entity as a point of coordination or calibration.
Yeah, and it's definitely fluid. You do this because, or you go to that meeting because you're leader in that or an authority in that part, and somebody else goes on the other meeting, and so the leadership is just more about fostering sending the right person than knowing everything and having to decide. This is the lonely feeling of leading, is that you have this idea that I need to help, I need to know best, but it's very much about listening and supporting the people, and then kind of create this willingness to work together from there. I guess the new leading is supporting somehow, but
I want to bring this back to our discussion about trust as well, right, from the very beginning, because this is reminiscent of the whole blockchain movement that started 10 years ago around the previous financial crisis, 2007-8 financial crisis. Satoshi created this Bitcoin currency as a so-called trustless system because there was a lack of trust in these central agents, these trusted third parties of the financial network, which are the banks. The banks are the routers or trusted signatories of the financial system, and they became bad actors, and their reputations caused them to lose trust in the population generally. And so these sort of anarchists, if you will, or libertarians, decided to create a system of so-called trustless computing in which everyone could be part of the network and validate each other by signing off on each other. So it was a peer-to-peer network. It was the second of these two options that we just talked about. Instead of having a single point that you all agree to follow, you would now have to form that trust relationship individually with everyone in the network, and then basically vote, will we accept this transaction or not? And then you start to see the enormous cost of that model of not trusting, that you have to verify, and not just verify one transactional point, one point of validation, but n points, where n could be a very large number. And this is why Bitcoin, does transactions on the timescale of minutes instead of microseconds, and is in no way capable of replacing the financial system that we have. Because when you forego trust, you basically add on an enormous cost in time, task, and territory. You need to include hundreds of other agents that may be unavailable, and it's not trustless, right? It's just you've shifted your trust away from these third parties now to trusting the software that you're using to communicate with a large number of people, and trusting that process has integrity from being exploited by bad actors as well. And there are, of course, exploit routes for the blockchain, which people don't talk about too much, but it is possible in principle to capture and pervert the course of a blockchain.
Yeah, that's yeah, it makes me think about the consensus algorithms within things like co-signing images or libraries or pull requests, and then I guess also being on the flip side, being more transparent. Like it isn't, for example, anymore one authority that hands out the SSL certificates. Now it can be multiple who hand it out, but now we're like making it transparent who does what, and that makes us make the choice or the decision to ourselves.
And this has been interesting at the sovereignty level, the national, sort of this growth of nationalism around the world. Now you see individual territories wanting to have their own DNS, their own trusted signatories, because they don't necessarily trust the American ones, right? So we're seeing this breakdown of trust all over the network, which is a totally natural function that will happen in any kind of network. So we can't avoid this trust issue. It is absolutely central to everything relating to the way we bound systems, draw boundaries, real or virtual. So coming back to this notion of invitation, I think the idea of invitation is a really important way to build the consensus at a deep level based on trust for harmonizing or homogenizing your security policy and any kind of policy for that matter, not just security. If you impose from the top, people maybe won't listen, and then you end up blaming them. But what if that was because they weren't invited to hear? If they've been invited, they were prepared to listen, then rather than being imposed upon, they would be ready to catch whatever message was important to form this consensus. And then we would be able to try again, building up a relationship iteratively on trust. Not necessarily in the same way that a blockchain might have done, much more efficiently than that, even with using a single leader as a seed. But let's look at the monolith versus microservice model from development, because I think there's some interesting stuff to see around this as well. There are different ways of presenting this, but I drew these two diagrams some years ago for a talk at QCon. What I'm trying to represent here is that there are these kind of virtual boundaries around things in a development pipeline, from dev, which is a bunch of programmers. So we've got a circle here showing developers, programmers forming a virtual boundary called development. And they're making a promise to deliver code. And the code is this module, a monolith of programming code, basically, M for module. And each of these modules promises tests, and the operations people do the tests and then eventually deliver the software to users. And the modules make promises to users as well. And it has this kind of arrangement. We can sketch it out, however simplistically, as what we'll call a monolith model. And you see there's a bunch of agents. They form parallel processes, if you will, so that none of the modules will work alone. They're all collaborating. We haven't shown what's going on the inside. But together as a group, all of these modules from the software are delivered to the users as a single kind of entity. Many problems with this. One is that the developers kind of throw the code over the wall to operations. The testing is kind of independent of promises being made to the users. And it's all a little bit uncertain what it is that's going to be delivered to the users in the end. Enter the microservice model, where we try to reorganize this around human concerns. We try to keep the agents or the humans together instead of the roles together. And it might be the same people making the promises to code, to test, and to do the operations, these so-called two pizza teams. And now each coding module forms the seed for coming together around something instead of the role of dev or the role of ops or the role of testing or the code itself. They're no longer the seed. The seed is operational completeness, if you will. So it's the same people, meaning that they have a closer relationship to all the parts of the process. And the theory is that by being involved in all of the steps, they have more trust because it's the same people and they trust themselves. And that they are closer to the users as well because they are interacting and getting feedback from the operational monitoring, if you will, of the service. So this concept of microservices kind of formed a reorganization of the roles around different seed points, a different form of collaboration. There's not necessarily less complexity here. There may even be more complexity because not only do the modules, although they take on the whole task of the thing themselves, but they have to coordinate with the other modules in the software. And somebody has to make sure that each one of those independent modules is now coordinated with the process or the promises being made to the end users. So some integration still needs to happen. And there are two ways of doing it, we discover. Either there's a seed which keeps all of the modules together, or each one of those modules has to form a peer-to-peer relationship with each one of the other modules. Two different ways of looking at a service model delivering to users. The old monolith, which forms its seeds of cooperation around different task boundaries, shifting to the microservice model where the seed is an individual part of a process, but still needs to be integrated at the level of the larger boundary or the interface between the system and the user. So this is a case, I think, where boundaries don't give you a clear answer about what is the best approach. And it's interesting for me to see the discussion of microservices go from everyone's all in and thinks it's the best thing since sliced bread to now people thinking, oh, perhaps we've gone too far. Maybe it's not all it was cracked up to be, and that it has problems of its own.
Yeah, I think it also shows where, if you look at each of the individual teams, also adding security to that, it's almost like the user now has become the patient in the story about the pharmacy and the doctor. They kind of have to almost try to solve across the different teams, and when there's an issue infecting two teams, like how will the user surface that, or how will that be dealt with in the system?
Exactly, that's a great point, because now it looks like the users actually have to interact with three different modules. Do they have separate security policies? Do they have the same one? And if they have the same one, how do they get there? Was it commanded to them by imposition from above? Did they figure it out peer-to-peer with one another? What happens when one module upgrades and another one doesn't? How do they maintain that coherence of moving as a single entity when they're now broken up into smaller pieces? So it's a different dynamic in this picture, which is, I don't think it's clear which one of these two models would work in a particular circumstance or not.
Yeah, and I've seen companies then add a new microservice, which is authentication, and a new microservice around that. So they kind of splitting up the securities again.
So again, time, task, and territory, or time, process, and space, there are these three issues that allow us to draw boundaries around agents. I think the simple summary is that boundaries are not barriers. We shouldn't mistreat them or misrepresent them as a reason to not make the right promises, to not get our policy right from the bottom up, because a boundary that isn't really a boundary won't protect you unless it completely isolates you from the world around you, and then it's not too useful.
It also brings up the whole discussion about separation of concerns, right? So where in the beginning it had to be, well, person A can only do that and person B can only do that, where it isn't that much about A and B not being able to do it as a group, as long as it's like clearly has a collaboration between A and B agreeing on what they're going to deliver there as well. So.
Just to kind of make fun of what happens when we try to wrap things in a boundary, maybe we use the boundary as a way of concealing all of the mess that's inside, the terrifying mess that's concealed within something. So scaling with boundaries, we did that with Dev and Ops, separating the roles. Did they become silos? Well, then we tried to do DevOps to connect them back together again. But the implication of that is an ongoing trust relationship, which actually reconnects them. I just wanted to tell a quick story here, which goes back to the so-called Garden City movement of the 1960s and 70s, which was popular, especially in South America. There was this idea that you could modularize cities, and software is very much like a city. It's a lot of little different pieces, different functional things that come together, and a lot of users interacting with it. What they discovered in towns like Brasilia in Brazil was that when they tried to separate the functions of a city into modules, they would have a residential part, a shopping part, a leisure part. They actually messed up the system, and people would spend their entire day in traffic trying to get from one part of the city to another to do the separate functions, because everyone needs all of the functions. So they created this enormous congestion problem in the network. Whereas if you compare that to a typical kind of Chinatown, you go down to the messiest part of town, it's chaos, there's people falling over each other, everything's happening all around you. It's incredibly efficient. And although it's always busy, there's efficient commerce going on at all times because everything is touching everything else. The distance between them, the barriers between them are very few. And this is the paradox of trying to separate concerns. It often leads to highly inefficient dynamical behavior, even though it maintains a clarity of, cognitive clarity, the separation of cognitive concerns. We pay the price, which is the congestion in the network between them. The final point, which you made yourself just a second ago, Patrick, is that even though we try to separate things into microservices or modules, there are other things that reconnect them back together again behind the scenes. We may try to suppress those things like DNS lookup, GitHub interactions for deploying and updating services code, monitoring systems which have to be able to get in and out of systems, even data flows between different parts, database backups and things like this. All of these kinds of processes which are below the surface, secondary to our core purpose, they may end up reconnecting our systems along lines that we thought kept them entirely separate. So then security starts to look a bit flaky or ill-conceived when it's trying to separate things that clearly need to be done for basic maintenance.
Yeah, and there's so many agents that we take for granted, whether that's an open source library, a cloud service, suppliers to our systems. Yeah, it's easy to abstract them away, but they're definitely there. So,
final point about security, the topic that no one wants to deal with, but that's attack. I think Promise Theory tells us something simple here too, relating to the boundaries. An attack is a kind of an imposition. If you like, an imposition is a prototype for attack. So if you try to throw a ball to someone, it might be helpful to them. If you throw them a sandwich, they might like that more than throwing them a ball, but still, even if it's good for them, they may not appreciate it. You can try to create a boundary to prevent the sandwich from reaching them, or you could simply say that we have a policy of not catching sandwiches. So that's another way of creating that virtual boundary. So again, attack, perhaps the primary focus of security for some cases, can be managed in the same way using the same kinds of lessons about promises as any other issue to do with collaboration. It's kind of defense is kind of anti-corporation, right? It's awareness and it's refusing to accept something which could be harmful. Perhaps promising even to be more discretionary about the kinds of things we're willing to do. That's the lesson around phishing, typically that people say, never open an attachment from a weird email.
We can't really say that our systems are attack-free, right? So that's a promise we cannot give.
Exactly.
But we can say for certain things that we kind of have receptors, whether that's like a DDoS maybe, or like we have some systems in place to kind of, or like tar pitting some people on the network or stuff like that. But there's always something that we can't defend or have no receptors for, and that almost comes back to the people inside the agent to deal with that.
So absolutely, we can't make a promise on behalf of another agent, so we can't stop someone from attacking us. The best we can do is control our own behavior, which is to switch off the receptor altogether. So we shut down the inputs, if you like, if we're being DOSed. Or we can also validate every packet as it comes in, try to do that. That's the proxy approach, the firewall approach. Obviously much more expensive because then you're validating every single item that comes in. foregoing trust. But these are the trade-offs that we need to make. Ultimately, it comes to a question of what we're going to do when something like that happens. Do we need to be agile enough to repurpose the system to change the promises that we make to avoid those attacks? Shut down one area, open up another, reprioritize resources to deflect, just as people are doing now around the coronavirus. Do we turn a shopping mall or a sports stadium into a hospital? How do we react to the promises we make and the purposes that we've assigned to certain agents? And then recovery, how do we recover from that, get back to the normal situation, stabilize our behavior to withstand the attack from outside, as is also a strategy often for DOS attacks, for instance.
Yeah, and these fire drills that we sometimes do, to keep up with these unknown situations or understand the system better, really help there as well. That we kind of know that we need to have certain receptors or solutions if things are happening. And then, of course, chaos engineering is almost like what we don't know. Yeah, and so we're putting ourselves already to the test by having systems killed or unknown states or all that stuff, just to be better prepared when they do happen with a bad intention.
Okay, I'm going to skip these slides here, but I wanted to look at this slide because I think there's an interesting lesson in this slide, which is that a tidy mind is not necessarily a secure mind. I think most developers would like the picture on the right-hand side better than the picture on the left-hand side. We tend to scorn what we consider to be messy and want to refactor it into something that's beautiful and modular. The lesson of the Garden City movement is that picture on the left-hand side might be far more efficient in terms of keeping its promises than the system on the right-hand side. And it might scale actually way better. So when we try to package things in nice packages, the risk that we run, I think, is that they're not able to keep their promises in a scalable way because we've tried to create an artificial boundary around something which limits the scope of the system, prevents it from growing with this and keeping the same promises at the same time. So I think this picture, for me, encapsulates an important lesson, which is that we shouldn't be too focused on things looking nice. We need to understand the promises at a deeper level than that and whether they're really being kept, especially as we change the constraints on the system and try to scale it, for example.
Yeah, it's quite very much like the cathedral and the bazaar approach, right? So the freedom to deal with the interactions, lots of interactions, whether compared to the other system, structured, less, like a lot more polished, but less connections, less interactions going on. So
that's a great way of putting it. Finally, failure modes, I think, are another thing that sort of relate to security and resilience and those related topics. I like to define 3 things to be a bit clear about the different ways in which a system can fail. And I talk about the 3 Fs: errors, faults, and flaws. An error is typically associated with the execution of something or carrying out a task. So we think of an error as being a mistake, something that was not intended, which happened while we were doing something. Whereas a fault, we can define as a promise not being kept. Whether it's a plus or a minus promise, an offer or an acceptance promise, it can still be a fault. And so every promise that we see in a promise diagram or an analysis is a potential fault waiting to happen. And a flaw is at a higher level, a promise that was made and it was possibly kept to the best of our ability, but it turns out that it wasn't fit for the purpose we actually intended. So it can be that we design a system it comes out entirely bug-free, exactly as we intended it to, but it still wasn't good enough because we didn't design it right. There was a flaw in the design. I think those 3 kinds of flaws are worth keeping in mind. And as we go deeper into the story of promises, we can analyze those things. I tried to do that in my recent book as a treatise on systems, give lots and lots of examples about how these kinds of faults and flaws can occur and how we can use promises to analyze them.
Yeah, and fault is a promise not kept reminds me of more of a bug, where flaw was a promise not fit for purpose is what is in the spirit of technical debt. It's like we design it like this, we executed well on it, and it's not like cutting corners, technical debt. It's more like we executed very well on it, but it wasn't the right solution, or it wasn't, and we learned from that.
Yeah, exactly. And at each one of these levels, there is a relationship ongoing, right? So back to our trust again, it's not just a one-off transaction. We push out a version and be done with. We're learning, as you say, from our mistakes the whole time, hopefully. And there are ongoing processes evolving in relation to the environment in which they're deployed. Very important. Something for our listeners to dig into if they want to, I think, this notion of the downstream principle, I think, is very powerful. It says that the further downstream you are, the closer you are to the outcome you're trying to make happen, the more responsible you are for making that outcome happen. The farther upstream you are, the less responsible you are. And this relates to continuity, operational, continuous, availability, reliability, and other issues as well. A quick reminder about what happens as we evolve systems over time. We try to make them less manual. We try to go away from this brain model in which we're command and control with our hands on, trying to do all the changes ourselves because we want to get our hands dirty. We try to scale it by stepping away from that to a society model in which we kind of program things to work by themselves, by cooperation, collaboration. We see that change happening all across society and technology, from individuals doing jobs to factories, from agriculture to hydroponics, from individual servers and system administrators to cloud computing and automation. It is as Simon Wardley would put it, the commoditization of things and moving up the value chain by standardizing and commoditizing things and taking people and thought out of the loop as much as possible. But the way to do that is to think very carefully about the promises being made and making sure that we can scale them.
So it reminds me of a lot of the security folks talk about that 90 or 80% of their security flaws is by basic things that could have been automated or tested or like put in like a hygiene thing. And that they finally have time when these things are under control to, do the more thinking or like the more complex stuff and work on that. And quite often we're still like debating, I'm not saying the simple things, but the things that should somehow get commoditized in the discussion. There are no special snowflakes or kind of that things that we can kind of make this consistent, and then we can level up. It seems to be like this maturity level that we have to go through ourselves.
Okay, I think we've reached the point where we want to open for questions again and stop talking ourselves and really get into a discussion with you guys on the other end of this. I just wanted to do a quick advertisement for the Promise Theory course, which is online. You can find it on Udemy or by searching my website, the Chiteki website. If you want to learn more about applying Promise Theory to leadership. And if you want to read more about Promise Theory, you can find it in these books, which you'll also find in the same places. So we can stop our presentation now, and I think we're going to open for questions and just general discussion until the end of the session.
And I can say the books are really helpful in understanding things. We merely scratched the surface of a lot of stuff, even though we spent like a lot of hours right now. But there's so much more to it. And I think what's important is that once you start thinking that way, you start to see the system, and that opens you to become more aware of what to do next or where to put your effort in just running around in a chaotic system where you don't know what to do next.
Okay, everyone, thank you